class. What's different about this one?
There's two radicals.
There's two radicals. So sometimes you might have to isolate two separate radicals, but what do you notice about anything outside either one of the radicals?
No.
No. So therefore, do we have to worry about step one at all?
No.
No, because there's nothing that I have to get rid of outside of either one of the radicals because they're already isolated. Okay? So what do I automatically do now to both sides?
Square.
Square both sides, exactly, because then that removes the square roots. So by squaring both sides automatically, I've removed the radicals already. So what am I left with over here, class?
3x minus 7.
Good, Brennan. 3x minus 7 equals?
X plus 11.
X plus 11. Good. Okay? Now by doing that, we can now solve this equation. But what do we notice we have now with the variables?
2x's
Variables on
each side.
both sides, right. So we need to do what?
Combine like terms.
Now, don't say combine like terms, because you're not actually combining like terms, because they have to be on the same side. We're going to collect the variables on one side, right? So combining and collecting is kind of a little bit different in terms of, if they're on the same side, we would say combine like terms. But in this case, we're going to subtract what from both sides?
X.
I would subtract x, right? Because if you subtracted 3x, do you still get the same answer? Yeah, but you're end up with a negative coefficient. We don't want to do that if we don't have to. So let's subtract the smaller from the larger and subtract x from both sides. Okay, so what are we left with over here?
2x.
2x
Minus 7.
minus 7 equals
11.
11. What do we now do?
Subtract 7.
Add
Or add 7.
Yep, add 7, good. Yep, add 7 to both sides. 2x equals 18, and now we do to both sides. Divide by 2. We get x is equal to 9. Good. Don't know if it's right yet, though. Not quite sure if I got it right then. What does that mean I do?
Check it.
Check it. Right, here we go. To check it, we're going to go the square root of 3 times, help me out, 9 minus 7 equals the square root of 9 plus 11. Good. And let's see if the two sides equal each other. Okay? What's 3 times 9? 27 minus 7. So I'm going to keep it as a square root of 20. Why do you think I want to keep it as a square root of 20? It's not a perfect square, right? Let's keep it, and let's see if the other side ends up being the square root of 20. All right, what's 9 plus 11?
20.
So do the two sides equal each other?
Yeah.
Yep. And now again, I could simplify that further, obviously, because obviously 20 is not simplified. But I know that if I were to simplify, they would be the same simplified radical. So they do check because they do the same. Huh? Well, example 4 is going to be a little bit different. So maybe what we'll do is maybe at the end, maybe we'll give you one that we can try yourself, okay? But this is our last example because it is going to be a little different. Okay, a little different. So I want to make sure I expose you to one like this. This is kind of taking us a little bit out of your comfort zone here with this last one, but it's going to be something you've already learned how to do when you come to the end here. All right. Now notice that I'm going to change the wording to this directions here. Solve and check for so what word did I add up there? Extraneous. Yep. Check for extraneous solutions. Extraneous solutions, class, are solutions that do not what? Work. Okay? All right, so that's what we call them extra, like they're extra solutions, something we don't need. Okay? All right, here's the actual problem right here. Okay, tell me how that one looks different. It equals x. It doesn't equal the square root of x. So, but do you notice that there's nothing outside of the radical on the left side? So therefore, do we have to worry about isolating the radical? No. So automatically, what do we now do automatically? Square both sides. Watch what happens when we square both sides though. You square this side, that's fine because it just removes the radical. Well, what happens over here?
It's x squared.
It's x squared. And we can't get rid of a square in this case because there's no radical there to get rid of. Okay? So automatically, what do we get on this side? 3 minus 2x. Perfect. Okay, but what is the other side equal to?
X squared.
X squared. And so now we've automatically made this a quadratic equation because we have a square now. So, but again, we had a whole chapter on solving quadratic equations, didn't we? Okay, so tell me right now, if I need to solve this equation, what do I need to get my equation set equal to?
30 or
0,
0.
right, 0.
I was looking at.
All right, so we automatically do what to both sides of class? Right, Maddie? All right, what do we do to both sides to set this equal to 0? What do we need to get to the other side with x squared?
Oh.
What do you think we need to do both sides? Because I don't want to do anything to the x squared. I want to keep x squared where it's at. Subtract 3 and do what to the negative 2x?
Add it.
Add 2x, right. So let's add 2x to both sides, and let's subtract 3. Now, do you want to do it in 2 steps or just all at once? All at once. So add 2x to both sides, and also do what? Subtract 3 from both sides. So by doing that, class, what have I done? I've got what over here? I've got, you got rid of everything and also set it equal to 0. So now we've got our equation, our quadratic equation, which we now can choose to solve this using what method, whatever method we want to use. Now we can always fall back to the quadratic formula, but as I look at this trinomial, this quadratic equation, it looks pretty easy using what method? So you guys remember? Let's see, factors of C whose sum is B. What is that called? It's called, I already used the word, factoring. Can we factor this quadratic into two binomials and then just set them equal to 0? So we're going to factor here, guys. We're going to factor. Okay, so watch. 0 equals, could we use the quadratic formula? Yes, but it seems to be a little more work than this is going to be. All right, so factor this into 2 binomials. First of all, guys, my C is what? Positive or negative?
Negative.
So how do we multiply? What are we going to multiply? Same signs or opposite signs to get a negative?
Opposite.
Opposite. So let's put a plus and a minus here. And what goes here and here to get x squared?
X.
X. And now let's put our C out here over here. Our C is negative 3. So what do we have to multiply by to get a negative 3, but when added equals what?
Negative 3 and 1.
To get to negative 3 and 1?
Oh,
3 negative
no.
Right, not negative 3, 1, but 3 negative 1, right? Because we have to get negative 3 when multiplied, but what is a sum? Positive 2, remember? 2 factors of C whose sum is B, right? And we know that's getting a negative, we have to have opposite signs. And in a positive 2 when added, we have to have the 3 has to be positive, the 1 has to be negative. So what number goes here? The 3. And what number goes here?
1.
The 1. Now, how do we solve these? What do we have to do to both of them? Set them equal to 0, right. So x plus 3 gets set equal to 0. And x minus 1 gets set equal to 0. And what are our 2 answers?
Negative 3 and 1.
Negative 3 and
1.
1. Now let's go back to what the example said to do for directions. Check and solve and check for extraneous solutions. Well, how do you do that? You look to see what solution doesn't actually work when you do what?
Solve.
When you go back and plug it in and check it. So let's put both these back in for x into both sides into the original equation now without the squares. So here's what I mean. Let's go ahead and check it using both these possible solutions. All right? And I'm going to change. I guess I can't because I don't know what marker one. All right, so let's go ahead and check. We're going to do the first of all, we're going to do negative 3. So back into the original equation, which was this. We're going to put in negative 3. So here we go. We're going to go the square root of 3 minus 2 times what, class?
Negative 3.
Negative 3 has to equal what? Negative 3. All right, what is 3? What's a negative 2 times a negative 3 become?
6.
Positive 6. What's 3 plus 6? The square root of 9, does that equal negative 3? No, what is the square root of 9? 3. Does 3 equal negative 3? No, so therefore what can we do with negative 3?
Get rid of it. Nice.
All right, so therefore that is an extraneous solution. Why? Because it does not check. It does not work. All right, let's go ahead and see if 1 works. Now we go ahead and put the same thing with 1. 3 minus 2 times
1.
1 has to equal 1. 2 times 1 is
1.
2. 3 minus 2 is what? The square root of 1, does that equal 1? Yep, the square root of 1 is 1, so 1 equals 1, so therefore it does check. So our answer for this one is 1. Negative 3 was an extraneous solution, it does not work. Okay? How do we feel about that? A little different, isn't it? So a little hint to yourself that if it's ever set, if it's set up in this fashion, you're going to have to make sure you factor. Because you're going to end up being a quadratic equation, you're going to square both sides, and this is going to end up being x squared. So whenever you see one where it's set equal to x, you're going to have to factor. You want to do one more of those, or do you feel like you're okay?